All right, welcome to This Explainer. Today, we're going to peel back the layers of reality and uncover the hidden chemical rules that are basically shaping everything around us. Seriously, we interact with some incredible chemistry every single day, usually without even realizing it's happening. From the meals we cook in our kitchens, to the stuff we use to clean our homes, right down to the fundamental biology keeping our own bodies running, it's all governed by this fascinating, invisible tug-of-war between acids, bases, and salts. So picture this. It's a super common scenario. Someone in your family is dealing with a painful bout of acidity after eating way too much at dinner. If you had to grab a remedy from the pantry right then and there, would you reach for lemon juice, vinegar, or a baking soda solution? Now, most of us instinctively know that baking soda is the absolute right choice for an upset stomach. But to truly understand why that works, and why the other two would honestly just make things so much worse, we need to become, well, chemical detectives. Here is our roadmap for today's explainer. 1. Spotting acids and bases. 2. Reactions and neutralization. 3. The power of pH. 4. pH in everyday life. And finally, 5. The magic of salts. Okay, let's jump into section 1, spotting acids and bases. You know, the absolute most basic way to tell an acid from a base is quite literally right on our tongues and fingertips. Acids are naturally sour. Think of biting into a lemon or some unripe grapes. Bases, on the flip side, are bitter, and they actually feel kind of slippery or soapy to the touch. But obviously, scientists don't go around just tasting unknown chemical compounds. Instead, we use indicators. Litmus paper is this classic natural indicator that's actually extracted from a lichen. Acids will change blue litmus paper to red, while bases turn red litmus back to blue. Oh, and that color-changing property? That is exactly why a yellow turmeric curry stain on a white shirt turns this crazy deep reddish brown when you scrub it with a basic bar of soap. Moving right along to section 2, reactions and neutralization. Now there is some incredibly volatile action that happens when you combine the right ingredients. For example, when you take an acid, something like dilute sulfuric acid, and mix it with a reactive metal, like zinc granules, you get this really powerful displacement reaction. The metal essentially bulldozes its way in and pushes the hydrogen right out of the acid, creating a salt, and generating these bubbling pockets of pure hydrogen gas. If you capture that gas in a soap bubble and bring a flame near it, well, it burns instantly with a highly satisfying, really distinct pop sound. It's just a spectacular way to witness dynamic chemistry taking physical form right in front of you. But hey, what if you skip the metals completely and mix an acid directly with a base? Well, because they're total absolute chemical opposites, they effectively just fight it out and destroy each other's properties. We call this a neutralization reaction. Those intense acidic and basic qualities completely vanish, leaving behind absolutely nothing more than a simple salt and some water. And if we zoom way into the microscopic world, we can see exactly why this happens. You see, acids and bases really only show their true colors when they're dissolved in water. Water is the great divider here. When an acid hits the water, it unleashes these positively charged hydrogen ions, or hydronium. When a base enters water, it releases negatively charged hydroxide ions. So neutralization is simply these positive and negative ions finding each other, locking together like puzzle pieces, and forming completely neutral water molecules. That brings us to section 3, the power of pH. To master all of this, scientists needed a precise ruler, and that's where the pH scale comes in. The P actually stands for potens, which means power in German, so it literally measures the power of hydrogen. It's basically just a measurement of those microscopic ions engaged in that dynamic tug-of-war we talked about. The scale runs from 0, which is extremely acidic, all the way up to 14, which is highly basic, or alkaline, and right smack in the middle is 7. A pH of 7 means perfectly neutral. It's the exact balance point where those acidic and basic ions perfectly cancel each other out, just like pure water. Let's dive into section 4, pH in everyday life. This number scale isn't just for laboratories either. Consider these critical numbers. Our bodies are unbelievably sensitive. We have to fiercely maintain a pH within an incredibly narrow range of just 7.0 to 7.8 just to stay alive. Out in the environment, if rain drops below a pH of 5.6, it becomes acid rain, which can completely devastate river ecosystems and kill off aquatic life. And get this. Right inside your own mouth, if the pH drops below 5.5, which is usually caused by bacteria breaking down leftover sugar, it creates an environment so acidic it actually corrodes your tooth enamel. And enamel is literally the hardest substance in the human body.
That's exactly why brushing your teeth with basic toothpaste is so vital. It actively neutralizes that dangerous acid.
And even nature gets in on this, using the pH scale for literal chemical warfare. Have you ever wondered why a bee sting hurts so incredibly bad? It's because that bee is injecting an acid, specifically methoic acid, directly into your skin, which causes all that burning irritation. But knowing your chemistry gives you a bit of a superpower here. You can brilliantly neutralize that painful acid by simply applying a mild base right from your kitchen. A little bit of baking soda on the sting, and boom, instant relief. Finally, let's head into Section 5, the magic of salts. So, as we established, when an acid and a base neutralize, they form a salt. And common salt, sodium chloride, is essentially a foundational raw material for modern industry. There's this incredibly clever industrial setup known as the chlor-alkali process. By passing a current of electricity through ordinary seawater, or brine, we literally force the salt and the water to break apart from each other. This process produces chlorine gas at one end, hydrogen gas at the other, and it leaves behind sodium hydroxide, which is a really powerful industrial base. Those raw materials are then transformed into a whole family of essential products that we rely on. We use that chlorine to create bleaching powder, which purifies our drinking water and keeps us safe from germs. We create washing soda, which is used to remove stubborn, permanent hardness from tap water, so our clothes actually get clean. And of course, we manufacture baking soda, which brings us right back full circle to the very beginning of this explainer. It's that mild, non-corrosive base that beautifully neutralizes the excess stomach acid causing your family members upset stomach. The magic of salts even extends into things like medicine and architecture. By very carefully heating a crystallized salt called gypsum to exactly 373 Kelvin, it loses some of its water molecules and transforms into a fine white powder that we call plaster of Paris. When a doctor mixes this powder back with water, it rehydrates and rapidly sets into a really hard solid. We are literally harnessing a basic chemical reaction to hold our fractured bones perfectly in place while they heal. It's pretty amazing when you think about it. Now, we can also combine acids with metal carbonates for some serious explosive utility, like literally building your own homemade fire extinguisher. It's just 3 simple steps. First, you put a sodium hydrogen carbonate solution, which again is just baking soda, into a bottle. Then, you carefully suspend a small tube of acid above it and seal the whole thing up. As long as those two don't touch, it's totally safe and stable. But the second there is a fire, you just tilt the bottle. The acid immediately spills into the baking soda base. This specific reaction between an acid and a carbonate rapidly evolves massive amounts of carbon dioxide gas. The internal pressure builds instantly, blasting the gas and liquid right out of the nozzle to aggressively suffocate the flames. It is controlled, violent chemistry that literally saves lives. So, you now have the detective tools to see the world totally differently. You know that baking a cake to make it soft and spongy, setting a broken bone, or soothing a painful bee sting, they aren't just random events. They are precise, predictable chemical reactions. This silent, acidic, and basic tug-of-war is happening all around you, constantly shaping the reality you live in. So, the next time you cook a meal, wash your hands, or even just take a breath, I want you to ask yourself, where will you spot this hidden chemistry next?